Every year, nearly 2 million people from 165 countries spend 5 days walking through one of the hottest places on Earth, and they all come home. One of them is an elderly woman from Kerala, her first flight ever, 71 years old, traveling alone into a crowd bigger than she has ever seen in her life. Crowds this dense follow the physics of fluids, and that physics has been deadly here before. So how exactly is she safe? By the end of this video, you'll see the machine built around one pilgrim's once-in-a-lifetime moment. Picture her if you can, an elderly woman from Kerala, standing very still in a river of white cloth. All around her, moving, praying, whispering, nearly 2 million people from 165 countries in a language she does not speak. She saved for this trip for 30 years, paisa by paisa, decade after decade. Everyone in her village knows why she went. Not many of them have been. This is her first flight ever, her first passport. At 71, in the summer heat of Arabia, almost certainly her last long journey. And here, in the biggest crowd she has ever seen in her life, she is trying to remember exactly how her son told her to walk. She has never left Kerala before this week. Nobody around her right now knows her name, and she is completely, quietly safe. That is the thing you're supposed to notice, because 100 years ago, even 50, she wouldn't have been. So let's do the math. First, the scale. In 2026, 1.7 million people performed Hajj, 1.5 million of them arriving from outside Saudi Arabia, from 165 nationalities. Most of them had never been to Mecca before. Many will never come again. They all have to be in the same places, in the same order, on the same days. Not roughly, exactly. Circle the Kaaba, walk between two hills, stand together on the plain of Arafat, sleep under the open sky at Muzdalifa, stone 3 pillars at Jamarat, in that order, in 5 days. Now add the second variable, the heat. Summer in Mecca regularly pushes past 44 degrees Celsius. The Hajj is outdoor by design, walking, standing, praying under the sun. There is no version of this ritual you can do from a hotel lobby. Here's the third variable, and this is the one nobody tells you: crowd density. When you pack more than about 6 people into a single square meter, something strange happens. The crowd stops behaving like people. It starts behaving like a fluid. Small pushes at the edge send waves through the middle. Individuals can't decide where to step anymore. They get carried, and if someone falls, the wave doesn't stop for them. Scientists call it crowd turbulence, and at Hajj, historically, it has been deadly. So, 2 million people, one of the hottest places on Earth, 5 days, a few square kilometers, and a crowd dense enough in the wrong moment to kill by physics alone. That is the problem. Now here is the question this video answers. How exactly does anyone solve that? The answer isn't one thing, it's layers. Let's go one at a time. Layer 1, the physics. The bottleneck of the whole pilgrimage was always Jamarat, the stoning ritual. 3 pillars, millions of pilgrims, 1 narrow bridge. Until 2006, it was a single-tier structure. Everyone converged toward the same 3 points, some coming in, some coming out. Same space, same time. In January that year, a crush at the base of that bridge killed close to 350 people. The single worst kind of failure, one that physics had been predicting for years. So Saudi Arabia demolished the bridge, all of it. What they built in its place is one of the most deliberate pieces of crowd engineering ever attempted. 5 operational levels stacked vertically, 950 meters long, 80 meters wide. The pillars themselves redesigned. Circular columns became long oval walls, so more pilgrims could reach them at once without funneling into a single point. And critically, one-way flow everywhere. You come in through one route, you leave by another. The 2 currents never touch. A German crowd scientist named Helbing worked with Saudi authorities to model it. From the 2007 season onward, every registered pilgrim was given a timetable and a route, distributed across space, distributed across time. Since that redesign, the Jamarat ritual has not had a repeat bridge incident. Layer 2, the eye above the crowd. Engineering can shape a space, but a live crowd still moves. It thickens, it slows, it surges without warning. Something has to be watching all the time, faster than any human control room could react. That something has a name. Two names, actually. Basir and Sawar. Both are AI platforms built by the Saudi Data and AI Authority together with the Ministry of Interior. Basir uses computer vision and large language models to read crowd flow at the entrances of the two holy mosques live. It doesn't just count, it predicts where density is building, where a surge is about to form, where the next bottleneck will be before it becomes one. Sawar is the wider net. 5,000 cameras, 80 locations, 16 AI algorithms, 31 data dashboards, 600 human operators watching around the clock. Every corner of the holy sites, every access road, streaming into one command room. The crowd never sees this layer. That's the point, because there is still one enemy no bridge and no camera can solve. In 2024, more than 1,300 pilgrims died at Hajj. The temperature that year pushed past 50 degrees Celsius. Heat is not a crowd problem, it's a physics problem of a different kind, and it requires a completely different layer of engineering. The Grand Mosque runs the largest cooling system on the planet, 155,000 refrigeration tons, split across two stations. Shamia, 900 meters from the mosque, carries 120,000 tons. Ajad, 500 meters away, adds 35,000 more. Together, they keep an area of 1.5 million square meters between 22 and 24 degrees Celsius, inside a place that outside is nearly 45. For the 2026 season, Saudi authorities added 50,000 more square meters of shade, 400 additional cooling units, thousands more medics on standby. Layer 4. The tent city. Between rituals, pilgrims sleep at Mina, 20 square kilometers of desert transformed for a few days a year into the largest temporary city on Earth. Over 100,000 tents, fire-resistant fiberglass coated in Teflon, because in 1997 the original cotton tents burned, air-conditioned, grouped by nationality so pilgrims can find each other in a place where nothing looks familiar. And inside a growing number of those tents, sensors, temperature, humidity, smoke. If any of them cross a threshold, the command center knows before the people inside do. Layer 5. The invisible logistics. Our elderly woman from Kerala, remember her, is walking through all of this. Between rituals, in heat, alone. She is not carrying her luggage. Nobody in this crowd is. In 2026, the Hajj without luggage service scaled to over 1 million bags, collected at departure airports in her home country, shipped separately, delivered straight to her hotel in Mecca, so that when she lands, she walks off the plane and gets straight on the bus. No queue at baggage claim, no suitcase to drag through a crowd. She was cleared through immigration in under 40 seconds. A biometric device took her passport, her face, and her prints in one motion, designed specifically to move elderly and disabled pilgrims through faster. So here it is, all 5 layers at once. Physics, vision, cooling, tent city, logistics. 5 interlocking systems, invisible to almost everyone who moves through them. And she, the elderly woman from Kerala, is at the center of every one of them. Behind all 5 layers, 441,000 workers, 26,700 volunteers, 40 different government agencies, working, most of them invisibly. And here is what all of it, from the physics of the bridges, to the AI in the control rooms, to the cooling towers, to the tents, to the biometric kiosks, actually means. It means that a 71-year-old woman from a village in Kerala, with no language in common, in the hottest place she has ever been, in the biggest crowd she has ever seen, can complete a ritual she has held in her heart for her entire life, and walk back out alive. She flew home from Jeddah, then Medina, then Kochi in 15 hours, and she is home. The mechanism she never saw kept her alive, so that she could carry this one moment back with her.